In the past, we've analyzed quantitative variables using different kinds of graphs and 5-number summaries. We've used dot plots, histograms, box plots, numerical summaries such as the 5-number summary, remember the minimum, Q1, median, Q3 and maximum, or the mean and standard deviation. That's if it's a fairly normal distribution. We've also examined the relationship between a categorical variable and a quantitative variable by using the categorical variable to create two groups and then analyzing the quantitative variable for each group. For example, we compared credit card debt, quantitative variable, for male and female college students, a categorical variable. For each student, we have two pieces of information, gender and credit card debt. In this situation, we use side-by-side histograms or box plots to compare the two groups. In this unit, however, we examine the relationship between two quantitative variables. For each individual in the dataset, we collect two pieces of quantitative information. For example, for a breakfast cereal, we record sugar content in a serving and calories in a serving. We use a graph called a scatter plot to graph the two pieces of information in 2 dimensions. Like you've probably seen in a previous math class where you have an x-coordinate system, an x-axis and a y-axis. So it's going to have 2 pieces of information, two kind of categorical pieces of information, and you'll plot it like a point. Like in this case, the number of calories and the number of grams of sugar in a breakfast cereal, that kind of thing. In a scatter plot, one variable is the explanatory variable, and the other is the response variable. The response variable is the focus of the study, the outcome that we examine. The explanatory variable is the variable that we think may influence the response. We can think of the explanatory variable as the predictor of the response. So now we'll look at an example of a scatter plot. Let's scroll down here. Okay. A research firm conducts a study to explore the relationship between a driver's age and the driver's ability to read highway signs. The subjects are a random sample of 30 drivers between the age of 18 and 82. Because the purpose of the study is to explore the effect of age on the driver's ability to read highway signs, 1, the explanatory variable is age, and 2, the response variable is the maximum distance at which the driver can read a highway sign, or maximum reading distance, we call it. Both variables are quantitative. Age is a number as well as distance is a number. So here's what our raw data looks like. Age is in the middle column, that's the explanatory variable. Distance is in the far right column, that's the response variable. And you can think of them almost like ordered pairs or points like we've seen in previous math classes. 18, 510 would be the first one, and then so on and so forth for all the rest. Okay, in this set, the individuals are the 30 drivers. For each driver, notice there's a ... They didn't want to include all the 30 drivers. It would be too big of a table, but you get the idea. There's driver 1, driver 2, driver 3, driver 4's information, and then you can imagine driver 5 through driver 29 is in there somewhere. For each driver, we have 2 values, age and maximum reading distance. To explore the relationship between age and distance, we create a graph called a scatter plot. To create a scatter plot, we use an ordered pair, like we were saying, x, y, to represent the data for each driver. The x-coordinate is the explanatory variable, the driver's age. The y-coordinate is the response variable, the maximum reading distance. Okay, for this example, the ordered pair 18, 510 represents an 18-year-old driver who can read a highway sign at a maximum distance of 510 feet. We plot a point for each ordered pair. In the scatter plot, each driver appears as a single point. Generally, each point in a scatter plot represents one individual. However, a dot can represent more than one individual. For example, if 2 individuals have the same variable values, then one dot will represent them both. The x-coordinate is the value of the explanatory variable for the individual. The y-coordinate is the value of the response variable for that individual. So notice here's driver 1's ordered pair, and here's driver 2 ordered pair. Okay, and if you plot those for all of these ordered pairs, you get a scatter plot. There should be 30 dots, one representing each of those 30 different drivers. There's the complete scatter plot. The idea here is we're going to try to see if there's a pattern between those dots. If you squint, it almost looks like a curve, maybe, even though some are a little bit off. But that's what we'd like to do is in this unit is to be able to see, is there a pattern? Do these look like they're basically a line? I mean, are they lining up in a line, or is it kind of a curve like this? What kind of a curve is it, or what kind of a line is it? And then maybe we can anticipate future drivers' reading distances using that model, that best fit curve, they call it. We'll see more about that later, but that's the reason you do a scatter plot. The explanatory variable is on the horizontal x-axis. The response variable is on the vertical y-axis. Sometimes the variables do not have a clear explanatory response relationship. In this case, there's no rule to follow. Plot the variables on either axis.